Okay. Now, it has come up a question similar to this in the 1988, but that's a long time ago. Okay. So a yacht in distress is 8 kilometers. So that's 8 kilometers south, 40 degrees west of a harbour, and it's drifting. It's drifting south 10 degrees east at 4 kilometers an hour. Okay. In what direction should a lifeboat travel in order to intercept the yacht if the speed of the lifeboat is 30 kilometers an hour? So lifeboat can go 30 kilometers per hour. Okay. So if you look at the very start of the question, you have a situation. Just draw yourself like a north, east, west, south axis. Okay. Okay. One of them is south 40 degrees west. So what's that mean? South 40 degrees west. South, then tilted 40 degrees west. Okay. That is the location of your yacht. That's the location of your harbour. Okay. Now, it itself is travelling south 10 degrees east. South 10 degrees east. What does that mean? So we draw another one. Like another little south 10 degrees east is going to be, I'll draw it in green. It's drifting down this direction. Here it's moving as well. Okay? And then in what direction should the lifeboat travel? The lifeboat itself will be starting where the harbour was. Okay? And because it specifies that there's an intercept, do you see the way it says there's going to be an intercept? What's the only way there's an intercept? If the lifeboat is actually faster than the object it's chasing, or the object it's chasing is basically going straight towards the lifeboat, or some direction towards, not away. Okay. So what I do in a case like this is I write down a list called magnitude and direction. Okay. I then decide on a formula I'm going to use. Which one am I going to fix? So in theory, if I fix the yacht to the spot, so I'm basically tethering the yacht to the spot, yacht can't move, and now I'm going to work with relative velocities. Okay. What happens to the yacht what happens to the lifeboat when it intercepts it? It has to travel along the initial displacement vector. It has to travel in that direction if the yacht can't move. So its relative velocity has to travel in this direction here. Alright, you get the gist. Its relative velocity has to travel in this direction here if it's to intercept the yacht. So I'm going to fix the yacht to the spot. So it's going to be velocity of lifeboat relative to the yacht. Phi L compared to the yacht, which is Phi L minus Phi Y. Everybody right with that? Now, what am I going to do? What angle do I already know? I already know that it's south 40 degrees west. I know that's 40 degrees there. Okay? So I'm going to do magnitude and direction, and what I always do is I always adjust that formula. So I adjusted that it's Phi L equals Phi Ly plus Phi Y. I always do the addition law of vectors. Okay, so I have Phi L, Phi Ly, and Phi Y. Now, what you can see here is that if I can get 4 out of 6 pieces of information, it's workable. I can just do cosine rules, sine rules, I'm going to get an answer. If I don't, just a 90-degree rule. So, velocity of the lifeboat, anybody? Says lifeboat can go 30 kilometers an hour. So velocity of the lifeboat, its magnitude is 30. Do I know the direction of the lifeboat relative to the yacht? What way does the relative velocity have to take it? South 40 degrees west, because it has to intercept it. South 40 degrees west, because I'm saying the yacht can't move. Okay, and finally the velocity of the yacht, I know it's drifting away at 4 kilometers an hour, which is 4 here, and then what I also know is its direction is south 10 degrees east. So now that I've interpreted that question, all I need to do now is it wants to know in what direction should the lifeboat travel. It wants to know the angle of the lifeboat. What way is that going to go? So I'm going to do the triangle lock, because that one equals this one plus this one. Which one do I have all the information on? So do you remember the triangle law? A has to start at the same position as either B or C. So if you imagine that's A, I can do it by linking B first and then follow it up by C. Or I could take the blue path where I start A and C off at the same position and I link them together using B. So what I'm going to do is I'm going to start with phi. I'm going to start with phi y because I have every ounce of information possible on it, and I'm also going to start with phi l. What direction do you think phi l would go in though? Probably somewhere around this direction here. One of the above. The maths will auto correct the angle that for you anyway, so it's not a big deal. Okay, so here's what we're going to do. I'm going to use that law there. So I'll start off with phi y. So phi y is going south 10 degrees east. That's 10 degrees there. It's going 4. Okay. Next I'm going to use phi l. So phi l is going to be going down this direction here somewhere, we don't know which one. Now, so I've started off velocity of yachts, velocity of lifeboat. Now where does phi ly join up? Can we tell where phi ly joins up? Phi l, no, it has to link in with basically that's A, that's B, and that's C. I started A and C at the same point. And remember, B and C got to link end to end with each other. Yeah. So if I said A is here, that gets me B, and that will be C. B and C always link end to end with each other. Yeah. So that means that what's got to be here, and it's gone in this direction here, is phi, velocity of the lifeboat relative to the yacht. And we know that angle, don't we? Yes?
The yacht and the lifeboat are mixed up in what time?
Sorry?
You have the yacht's supposed to be on the right side of that rather than the yacht's supposed to be on the left.
Oh, sorry, the lifeboat. Sorry, excuse me. The velocity of the velocity of the yacht is going that direction. We'll just do this one more time. Velocity of the yacht is going this direction at south 10 degrees east. That's velocity of yacht, yeah? Velocity of so that's phi y. It has to go end to end with phi ly, and phi ly is in that direction there. And finally, velocity of lifeboat is that side there. Is that right? Now, I need to figure myself out some angles. What angles can I use here? I've done some angles already, so I'm just going to draw in little cross threads here and here. So, what angles do I know? South 10 degrees east, right? South 10 degrees east. So what does that make that? 10 degrees right there, yeah? This one was south 40 degrees, west which in turn makes that 50 degrees. Makes that one 80 degrees, and by alternate angles makes that one 80 degrees. And what does that turn that angle into? 130. Okay? So there's your 130 right there. And that's what you were looking for. You were looking for just one of those central angles. Right, did that other one disappear on me? Here we are. So that's 130. Okay, I see. It's just right over 130, yeah? What do we know about VL? It's going 30 kilometers an hour, isn't it? What do we know about Phy? It's going 4. So this whole triangle now turns into 30 in length, 4 wide, 130 in the middle. And what exactly are we looking to find out again? We're looking to find out what direction did the yacht take. So if we do a little cross thread here, if we figure out this angle here, we can figure out what direction did the yacht actually take. Okay, so we just do the sine rule. So what's it? Sine 130. Sine 130 over 30. Call that x. Sine x over 4. Okay. Will somebody sine inverse x will equal sine inverse 4 sine 130 all over 30. Will somebody give me that? Wherever it is. Anybody got it?
5.86.
Was it?
5.86.
Is it 5.86? Okay. 5.86 degrees, yeah? Okay. So it's a very sharp angle. Now if that's 5.86, what does it make the top angle? Add them up and take it away from 180. About 44.14. Is it? Yeah? Okay. Now, okay, you did this earlier. Remember we said earlier that this part here, just highlighting it, that part there was 10 degrees, wasn't it? The part directly to the left was 80. So what does that make that then? That makes that part 80. That makes that 44.14. Add them together and take them away from 180. And what you get? 55.86. So my argument is that this boat goes east 55.86 degrees south. Or that can be written as south 34.14 degrees east. Both questions are identical. Is that alright? Now, that's an intercept question, okay? The next type of question is, that's also an intercept question. I'll do that one afterwards. This one here is not an intercept question. A ship X is located 50 kilometers due west of a ship Y. So X and Y are here. That's X, that's Y. Ship Y is heading south at a speed of 10 kilometers an hour. So ship Y is actually still moving. The speed of ship X is 7 kilometers an hour. So velocity of X is 7, velocity of Y is 10. He's going south. We don't have a direction for this guy. And what direction should X head to get as close as possible to Y? What is the shortest possible distance between the two ships? Okay, now this question is a bit different. First of all, select one of them to be stationary. Which one's like? We'll select Y, I suppose, yeah? Ever cool with that? Select Y. Now, We're going to fix y to the spot. Y can't move. Now there's a problem here. No matter what x does, what's going to happen? What's going to happen? Now this is where the guesswork comes in, right? This is where a bit of intuition comes in. I'm going to do the relative path now, okay? Is it possible for x just to go straight across and clock y out of it, relatively speaking? If I fix y to the spot? No. Will x close up y going left to right? Just going left to right, can x close in y? Okay, so what's happening is every second y goes down at 10. X has a choice. Would x go diagonally right up in pursuit of y? What? Absolutely not. Because you're reducing your x and y component that way, yeah? So realistically, when you're speaking about x, it's either going to go straight across at 7, or it's going to angle slightly down at 7. Would that make sense? Yeah? Okay. Now here's the real clincher here. What is the relative path of x to y? It's definitely losing ground going in a southerly direction, isn't it? It can't match that 10 kilometers an hour going south. So technically x is going to drift north in comparison to y. Would you agree with that? Because y is travelling faster south than x is, when you're an observer on ship y, you're looking at x drift northward, yeah? But you're also seeing x close you in, coming from the west, closing you in towards the east. Does that make sense? So my guess on the relative velocity, or the relative approach, is that x goes towards y in a left to right direction, but it's drifting northwards. That makes sense? So it's drifting northwards up that direction there. Okay? So, once again, like every other question I've done, I'm just going to make a quick list of magnitude and direction. Okay? So here's where the part kicks in. Right? So magnitude and direction. Okay? So mag there, magnitude, direction. There's going to be 6 pieces of information. And I'm saying phi x, y is kept stationary. And then I'm going to say that phi x equals phi x y plus phi y. Once again, using the triangle rule. Phi x, y, phi y. Now, look at this. Magnitude of phi x, 7. Magnitude of phi y, 10. Direction of phi y, south. There is nothing left. There's nothing else I can do here. I have 3 pieces of information instead of 4. So here's what we're going to do. We're going to construct our triangle like we did last time. What way do we think phi x is going to go? Either directly to the right or slightly down, isn't it? So we can draw phi x, take an estimate that phi x is going this way. What can we say about phi y? Can we start phi x and phi y at the same spot? Can we start them at the same spot? Okay, once again, bring back the triangle law. Okay, if I have a vector A, I can start it off with C and follow it up with B, or I can start B off at the same spot as A and follow it with C. Okay, it doesn't matter which way I do it. It's very important you understand the triangle law, okay? Now, what I'm going to do is I'm going to start phi x and phi y in the same spot. So phi x is this way and phi y just goes down this way here. Okay? And what direction did we say phi xy is going to be in? That's phi xy there, isn't it? The green line? So it's going to be arcing slightly, diagonally right up, yeah? So I'll just complete this graph with that. I'll make that slightly longer if I can. One sec, guys. So this is phi y going this direction here, and then that's phi x, y. Does that obey the triangle law I set up at the top of the board? Phi x equals phi xy plus phi y. Does it obey that rule? It does. So we're in business there, right? Now, problem is, we've got absolutely how many angles? We have no angles, okay? Now that's the killer on this question, right? So here's what we're going to do. We're just going to fill in our numbers. We know that phi x is 7. We know that phi y is, anybody? Phi y is 10. You're going to line up angles up. You have to use a sine rule, and you're going to line up the angles opposite this. So that's going to be angle A, and that's going to be angle B. Now, one of the sine rules will be impossible, the other one won't be. So I'll explain what I mean there in a second. Sine B over 10 equals sine A over 7. Now, to get as close as possible, I need this angle here to be as acute as possible. Do you agree with that? The smaller that angle is, the closer I get to y. Does that make sense? So, where does that angle link in? So, it's actually this little angle here, isn't it? So the larger A is, the closer I actually get to y. So I want A to be really large. Now if you don't understand this, there's a really easy way to learn it off is that when you see this one here, you're going to have to set either A to 90 or B to 90. One of them, when you have three pieces of information, one of them always turns to 90. Now if I set A to 90, if I set A to 90 degrees, what will happen to sine A? 1, and then I'll get sine B equals 10 over 7, which is not possible because the maximum value of sine is always 1. That was the wrong choice. So instead of saying A to 90, I'm going to set B to 90. Now B being 90, when you set B to 90, it gives you the maximum value of sine A. So you're going to get sine A equals 7 over 10. If B wasn't 90, it would give a smaller value for the angle A. A wouldn't be its maximum, okay? So sine inverse 7 over 10 for me, what you get? So we're just going to sine inverse 7 over 10, what you get?
44.43.
44.43. Okay, and then what does that mean? What's the point of the question again? What direction should AX head in? So, I have to find out what this angle here is, or this one here. So 180 minus 90 minus 44.43. What you get? 180 minus 90 minus 44.43.
Hey, good morning. Would all 6 tutors for tutors in here?
45.57. So look guys, we've answered the first question. X should go, see that angle there guys? That angle there, we'll just wait a second. That angle there guys, is that both X went south 45.57 degrees east. Does that make sense? Now, I also know this angle here now, don't I? That's 90 minus that angle there. It's still 45.57. So when I go back up to the very top diagram, and I'll just get rid of that there for a second. This diagram here means that this is 45.57. Its initial distance is 50 kilometers. I want the closest distance D, don't I? So it's going to be sine 45.57 equals D over 50. Last one guys. D equals 50 sine 45.57. What do you get there? 85 points. 35.7 kilometres is the closest you'll get.